Since time immemorial, humanity has looked up to the night sky, filled with wonder and awe, yet also shrouded in mystery. From ancient civilizations that built monuments to the stars, to modern-day scientists who develop complex mathematical models to understand the workings of the universe, we have always felt the pull of the cosmos. It is both a source of inspiration and a vast unknown, one that evokes profound questions about our existence. Where did we come from? Are we alone? What is the universe made of? The night sky is a window into a cosmos that stretches far beyond the confines of our planet. But for centuries, we have been limited in our ability to see what lies within it. Our eyes, despite their incredible abilities, can only detect a sliver of the electromagnetic spectrum, the visible light that represents just a tiny fraction of the universe's full story. In order to unlock the deepest mysteries of space, we needed to develop instruments that could peer far beyond the limits of visible light to reveal what had been hidden from our view. The James Webb Space Telescope represents the culmination of this quest for deeper understanding. It is not just an advanced scientific tool. It is humanity's boldest attempt to push past the boundaries of what we can know, to embark on a journey that will illuminate the unseen dimensions of space and time itself. The very nature of the universe is woven with electromagnetic radiation of all kinds, from gamma rays to radio waves and everything in between. The universe does not just speak in visible light, but in a symphony of wavelengths, each telling a different story. When we turn our attention to infrared light, we unlock a new language, one that can penetrate cosmic dust clouds, observe the early formation of galaxies, and reveal the birth of stars, all hidden from our view in visible light. Infrared radiation is the key to Webb's mission. Unlike visible light, which is easily scattered by interstellar dust and gas, infrared radiation can pass through these cosmic barriers, providing a clearer picture of the events unfolding in the farthest corners of the universe. It is also the light that ancient galaxies and early stars radiate, a faint glow that Webb's instruments are perfectly designed to detect. This ability to see in infrared also allows Webb to peer into the coldest and darkest corners of the cosmos, where stars and planetary systems form. In these regions, infrared light reveals the secrets of star formation, the creation of planetary systems, and even the building blocks of life. Webb doesn't just reveal what is, it shows us what was and what might be, connecting the present to the distant past and the potential future of the universe. The James Webb Space Telescope didn't come into being in a vacuum. Its creation is the result of decades of work by scientists, engineers, and technicians from all over the world. NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, collaborated to create the most powerful space observatory ever constructed. This global effort speaks to the universal human drive to explore and understand, a drive that transcends borders and cultures, uniting us in a common purpose. The creation of Webb is a testament to the power of interdisciplinary collaboration. It involved not just astronomers and engineers, but also experts in materials science, optics, communications, and artificial intelligence, among others. Together, they overcame unimaginable challenges, from building a mirror that could be folded up and deployed in space, to designing a sunshield the size of a tennis court that could protect Webb from the heat of the sun. These monumental feats required innovative problem-solving and extraordinary teamwork. But Webb's creation is also a symbol of hope, a beacon of what humanity can achieve when it sets aside differences and works together toward a shared dream. It represents the best of human spirit and the belief that no challenge is too great when we work collectively, using our collective knowledge and resources for the advancement of all. Webb's journey to the second Lagrange point, or L2, located 1.5 million kilometers from Earth, is no small feat unlike its predecessor, the Hubble Space Telescope, which orbits Earth. Webb had to travel far beyond our planet to an area where the sun's radiation and the Earth's heat would not interfere with its infrared observations. Reaching L2 was not simply a matter of sending the telescope into space. It was a carefully calculated journey through the cosmos, one that would take over a month. At L2, Webb will be shielded from the heat of the sun, the earth, and the moon, providing a cold and stable environment for its delicate instruments. It will also allow the telescope to remain in line with Earth as it orbits the sun, offering an unobstructed view of the universe. But this journey, while exciting, was not without risk. Once Webb was launched, it would be on its own. There would be no way to repair or service the telescope once it was in space. Its success depended entirely on the accuracy of its design, its engineering, and the precision of its launch. The risks of sending Webb so far from Earth were immense, but they were outweighed by the potential rewards. Webb's mission was more than just a scientific undertaking. It was a bold step into the unknown, a demonstration of humanity's willingness to take risks in the pursuit of knowledge. At the heart of Webb is its golden mirror, a sophisticated and awe-inspiring feat of engineering. Each of the 18 hexagonal segments that make up the mirror is coated in a thin layer of gold, chosen for its ability to reflect infrared light with exceptional precision. The size of the mirror is also crucial. At 6.5 meters across, it is significantly larger than Hubble's mirror, giving Webb the ability to capture far more light and resolve even finer details. To achieve this precision, Webb's engineers used beryllium for the mirror's structure, a metal chosen for its stability at extremely low temperatures. But designing and building the mirror was not an easy task. Each segment had to be crafted with atomic-level accuracy. Even a small misalignment could compromise the telescope's ability to produce sharp, clear images. The mirror had to be not only functional but perfectly tuned, with every surface optimized to reflect the light from the farthest corners of the universe. This mirror is not just a reflection of light. It is a reflection of humanity's relentless drive to improve. It represents the culmination of generations of work, from the early astronomers who first used telescopes to the scientists and engineers who, today, continue to build on those foundations. When Webb begins its observations, it will provide us with more than just images. It will provide us with answers to some of the universe's most profound questions. For centuries, astronomers have tried to understand how galaxies form, how stars are born, and how the universe evolved after the Big Bang. Webb's infrared capabilities will allow scientists to peer back in time, observing galaxies as they were just hundreds of millions of years after the Big Bang, an era we've only been able to theorize about until now. Webb will also allow us to study supermassive black holes, the mysterious giants at the centers of many galaxies, including our own Milky Way. These objects exert an enormous gravitational pull, influencing the formation and behavior of entire galaxies. Webb's ability to observe the infrared emissions from these black holes will provide new insights into their formation, growth, and the role they play in shaping the cosmos. But the most profound implications of Webb's discoveries may lie in the earliest moments of the universe. By looking back to the first galaxies that formed after the Big Bang, Webb will help scientists test their theories about the origins of the universe. It is a step into the deepest realms of cosmology, where time itself becomes a malleable and mysterious concept. Perhaps one of Webb's most profound contributions will be its role in the search for extraterrestrial life. As we explore distant exoplanets, Webb will analyze their atmospheres for signs of habitability. By detecting the chemical signatures of water vapor, oxygen, carbon dioxide, and methane, Webb could help answer one of humanity's most profound questions. Are we alone in the universe? This search for life is not just about scientific curiosity. It taps into something deeply human, the desire to understand our place in the cosmos and to know whether life, in its various forms, exists elsewhere. With Webb's unprecedented abilities, scientists will be able to study planets in detail like never before, investigating their atmospheres for the markers of life, even on planets orbiting stars light years away. Webb represents not just a scientific leap, but a testament to the potential of humanity. It embodies the vision, the ingenuity, and the tenacity of thousands of individuals working together to achieve something once thought impossible. It is a symbol of what we can accomplish when we push beyond our limitations and take risks in the name of knowledge. As Webb peers into the cosmos, it will uncover not just the mysteries of the universe, but also reveal something about ourselves. Through these discoveries, We will not only learn more about the cosmos, but also about the boundless potential of the human spirit to reach beyond the stars and seek understanding, no matter the distance or challenge.